Charles Moore's journey was far from easy. For a long time, his reports and warnings were dismissed, and his research was not taken seriously. And there were reasons for that. The oceanographer was urging governments worldwide to reduce plastic production and consumption while allocating substantial funds for its recycling. His request wasn't just for a little, but a significant amount of money. Yet, Charles achieved something crucial. He shook the global environmental community and drew attention to the plastic pollution in the world's oceans. But at the same time, no one fully grasped the danger of what had happened to the oceans and its impact on the life on our planet as deeply as he did. And Charles took the first step. That is, he uncovered a problem. But how does this discovery affect each of us? And what is next? How can we prevent the catastrophe from escalating? To answer these questions, we must first understand how global ocean system works and how it was damaged so severely.
Functions of the ocean. The ocean is a vast world that captivates our imagination and scientific curiosity. Its ecosystems, like intricate clockwork mechanisms, maintain the delicate balance necessary to sustain life on Earth. The ocean functions as the planet's natural air conditioner. It absorbs heat and gradually releases it. Remarkably, just a 10-meter layer of ocean water can store more heat than the entire atmosphere. The ocean's heat capacity is a unique ability that moderates temperature fluctuations between day and night, as well as between seasons, such as summer and winter. Ocean currents circulate around the planet, transferring heat and nutrients from equatorial regions to the poles and vice versa. This process mitigates temperature extremes. Ocean temperatures influence the life cycles of animals and plants, both in the ocean and on land. The ocean actively affects atmospheric processes, contributing to cloud formation and precipitation. Every day, vast amounts of water evaporate from its surface, condense into clouds, and return to land as rain or snow. This process is crucial for replenishing rivers, lakes, and soil with fresh water. Microscopic algae, such as phytoplankton, produce about 50% of the oxygen humanity breathes. Every second breath we take is a gift from the ocean. The ocean is also home to millions of species of living organisms, from tiny microbes to majestic whales. It harbors species that have existed for hundreds of millions of years. The ocean is where life began, and the future of our planet depends on it.
The ocean is a single interconnected organism that encompasses all of our planet's water resources. But as it turns out, this incredibly complex living system is very ill. And the reason for this is our careless handling of the plastic after its use. Plastic is a remarkably durable and convenient material, yet plastic pollution is a poison to the ocean. Charles Moore was the first to recognize that the
Per
true scale
Google
of this
Lens galima rasti tiesiogiai nuves į kanalus, o šiaip tai... Palaukit, kaip čia. Rusiškai galiu pasakyti. Rusiškai Время правды, o angliškai Time for...
Charles launched a second expedition to thoroughly investigate the so-called garbage patch.
Kaip skaitosi?
And the findings from this expedition astonished the scientific community.
But in 1999, that was truly the discovery, because in 1999, after we analyzed our samples, we realized that there was 6 times as much plastic in the surface waters by weight as zooplankton, the basic food of the ecosystem. So the fact that plastic outweighed the life in the ocean was alarming to so many different people.
The Great Pacific Garbage Patch is, in fact, the largest dump on the planet, growing rapidly since the 1950s. This oceanic dump stretches from the west coast of North America to Japan. Its area varies, but is estimated to be around 1.6 million square kilometers, or 580,000 square miles. The garbage patch contains at least 80,000 tons of waste. And this is just the tip of the iceberg. Approximately 70% of plastic sinks to the ocean floor, where a significant amount of marine debris likely resides. No one knows the true amount of trash within the Great Pacific Garbage Patch. The North Pacific subtropical gyre is too vast for scientists to study comprehensively. Measurements show that the garbage patch is growing at an alarming rate. From 2015 to 2022, the average mass of plastic within it increased 5-fold, while the number of smaller plastic fragments grew 10-fold. Marcus Erickson, research director at the Algalita Marine Research Foundation, USA, noted, "The original idea that people had was that it was an island of plastic garbage that you could almost walk on. It is not quite like that. It is almost like a plastic soup." The Great Garbage Patch is becoming the planet's 7th continent, but it is not the only one. Today, scientists have identified 5 major garbage gyres, 2 in the Atlantic Ocean, 2 in the Pacific Ocean, and 1 in the Indian Ocean. Millions of tons of plastic and other debris float in the oceans. According to research, up to 80% of the trash in these patches consists of plastic waste. Garbage islands are growing at a catastrophic rate. If we look around, we'll notice the following. 8 out of 10 items around us are made of plastic. We sleep on pillows with plastic filling, brush our teeth with plastic toothbrushes, and drink from plastic bottles. You are watching this film on a screen made of plastic, whether it's a TV, laptop, or phone. It's simply impossible to imagine our modern life without this material. The world around us has become plastic.
Naktį
Plastic
jisai
is
jau
one of
buvo.
humanity's most
Aš
pressing
vakar
problems
bandžiau
today.
žiūrėti, bet taip ir
We decided
nesugebėjau.
that because there was no focus on plastic pollution, we would take the lead,
Iš Google Lens padarius screenshotą nuvestų
create what came to be known as the Great
tiesiai į
Plastics
kanalus,
Awakening, the
kurią
awakening to
kalbą
the idea that
pasirinkus.
this material that is probably the most common material in our daily lives. I like to say that next to sleep, the most time that we waste is opening things wrapped in plastic, because we take so much time just taking things out of the plastic that covers everything.
What are the
Tikrai
disastrous
plastikas
consequences of
plastike.
uncontrolled dumping of plastic waste into the world's oceans?
And the basic problem is that plastic, unlike other substances, doesn't go away. It remains in the environment. It doesn't go through the normal biodegradation cycle. It was invented to defeat
Labai svarbu
natural
šito
decay.
filmu ir
So in
dalintis.
defeating natural decay, it made itself a permanent
Gal
part
netgi
of our environment.
asmeniškai turbūt net nežinau kaip čia yra.
So now we have a basic understanding of the Great Garbage Patch. Its size is truly enormous, and it continues to expand. But what is happening at the heart of this disease? Maybe plastic simply float in one place and eventually sinks into the ocean depths where they decompose under immense pressure. Maybe this is as alarming as it seems. So what have we learned so far?
Decomposition of plastic into micro and nanoparticles.
It is now one of the leading
Labai geras
causes of
turinys.
death of marine creatures and needs to be investigated on that basis as a killer. It's a predator that kills but never eats. And it's also something that's predated upon, that fills up stomachs
Daug
without
statistikos.
giving nutrition. So it has a black, dark, evil side that is both killing and being consumed and killing. It strangles and it fills up bellies, and it's doing that at a greater and greater level, and that's just at the microplastic level.
Every year, more than 400 million tons of plastic waste are produced globally, and by 2040, this figure is expected to triple. Around 11 million tons of plastic enter the world's oceans annually, the equivalent of over 1 garbage truck of plastic dumped into the ocean every minute. Currently, our oceans already contain approximately 200 million tons of plastic. Studies suggest that by 2050, the amount of plastic in the ocean will likely exceed the total weight of all fish. Plastic takes 500 to 1,000 years to decompose. The Environmental Protection Agency states that basically 100% of all plastics human beings have ever created are still in existence. This waste does not disappear, it only accumulates. Imagine a dumpster in your backyard where trash is constantly added, but no one ever removes it. What would that dumpster look like after a month? Plastic waste floating in the water column becomes trapped in ocean currents, carried to central regions of the ocean, and forms massive garbage patches. These areas contain items such as fishing nets, disposable bottles, packaging, toilet seats, dolls, traffic cones, soccer balls, rubber ducks, and even TVs. Plastic doesn't biodegrade. However, under the influence of wave action, salt water, and sunlight, it breaks down into small fragments, sometimes invisible to the naked eye. These tiny particles, known as microplastics and nanoplastics, retain their polymer structure. The breakdown process continues down to the molecular level. The amount of microplastic, how much of it is there? Microplastic particles resemble a fancy mosaic. They are formed from various types of plastics and chemical additives, which change depending on their stage of degradation and environmental exposure. As a result, microplastic in the environment cannot be viewed as something fixed or constant. Studying it is a true puzzle for researchers. Although the exact amount of microplastic in the oceans remains unknown due to technical challenges in detection,
Mikro,
theoretical
nano,
calculations help
dar
illustrate the scale of this
mažesnis,
threat.
tai kraujyje,
Given
spermoje,
that currently an estimated 200
virusų
million metric tons
klidėse.
of plastic waste
Čia
are present in the
pasakys.
oceans, we can do a thought experiment. If we imagine breaking all the plastic in the oceans into 50 nanometer particles, considering their density and the volume of the world's oceans, The resulting number is horrifying. Each liter of ocean water would contain 286 million of such particles. While not all plastic in the oceans has yet degraded into micro and nanoplastics, we understand that sooner or later it will inevitably fragment into countless nanoparticles. Already today, scientists detect microplastic particles in every drop of ocean water. Moreover, there are regions within the ocean where the concentrations of microplastics are significantly higher. Most global scientific studies describing the scale and volume of marine plastic pollution have been limited to the ocean's surface layer. Research shows that approximately 358 trillion microplastic particles are floating on the surface of the world's oceans. However, growing evidence indicates that countless trillions of microplastic particles are also present in deeper waters and seabed sediments. Lightweight plastics tend to remain afloat, while denser plastics, or those colonized by marine organisms, sink to the ocean floor. According to estimates, about 50% of plastic waste from urban sources has a higher density than seawater, causing it to settle on the seabed, be carried by deep-sea currents, and accumulate in trenches and depressions. Microplastics have even been detected at the deepest point of the ocean, the bottom of the Mariana Trench. In reality, it is not the ocean's surface but the deep-sea floor that serves as the primary repository for microplastic debris. Consequently, the entire seabed is gradually being covered with a plastic layer. However, data on ocean pollution by microplastics are underestimated, and the reality is far worse. Not everyone has access to very sophisticated and expensive instruments and sampling tools, explains Melanie Bergman, a biologist at the Alfred Wegener Institute in Germany. In her opinion, as much as 90% of marine microplastic particles may be missed by standard sampling techniques because they're too small to be detected. The highest concentration of plastic is in garbage patch zones. These oceanic dumps act like factories for the continuous production of microplastics. Similar to how a virus spreads through the bloodstream, microplastics are dispersed throughout the global ocean system by currents.
Labas vakaras, Miguel.
Since oceanic gyres are present in all the world's oceans, microplastics accumulation is occurring on a global scale. Even a remote and uninhabited region like the Arctic is no exception. Ice core studies have shown that microplastic pollution levels in the Arctic Ocean are 2 orders of magnitude, 100 times, greater than those in the Pacific Gyre. In addition to the 2 layers of pollution, the surface and the bottom layers, the concentration of microplastics significantly increases in another area, the thermocline. This is the layer of water where temperature changes sharply with depth. Due to high-density gradients in this layer, micro and nanoplastics become trapped, remaining suspended there for extended periods. Picture the ocean as a layered cake, where each layer has distinct temperature and density characteristics. Microplastics tend
Aš
to
girdėjau,
accumulate at
kad
the
taip
boundaries between
vers
these layers.
Raimondas pats
Additionally,
pasisiūlė
microplastics can also be
garsinti.
transported in the ocean
Tai
by
tikrai
marine
vers
organisms that
būtinai.
ingest, digest, and excrete plastic particles.
It's now undeniable that
Jis
microplastics are everywhere.
netrumpas, kaip
They're
matot.
present in all bodies of water.
Beveik 2
Ocean,
valandos,
rivers,
bet
and lakes
labai
on our
įdomu.
planet are all interconnected. But some may argue, well, okay, fine, but microplastics are so small that they're not something that I should worry about, right? I mean, I don't see them in the water that I drink or in the tomatoes in my salad, even though they were grown with water, which is all part of an interconnected global water cycle. So maybe they're not as dangerous as they seem. But are they?
Microplastics, a source of toxins and bacteria. Influenced by sunlight and waves, plastic breaks down into small particles, releasing dyes, plasticizers, and other chemical compounds
O
into the ocean
Dainiau,
water.
tu randi
Many of these
YouTube
substances
šitą
are toxic.
filmą?
As a result, ocean water turns into a toxic soup.
Nu, va, bent jau pagal tuos
Plastic
screenshotus.
continually breaks down into micro and nanoplastics, making the ocean increasingly toxic. Studies have shown that nanoplastics are more toxic than microplastics due to their greater ability to act like a sponge, absorbing pollutants from water and air. The surface of plastic waste becomes home to harmful algae, colonies of bacteria and fungi, which rapidly multiply.
Įdomu, ar lengvai randama, nes aš neparašiau pavadinimo. Ir taip daug nusižengimų darau, rodydami.
Moreover, plastic debris can serve as a bridge that allows coastal organisms to reach the open ocean, disrupting the fragile balance of ecosystems. As a result, these garbage islands become breeding grounds for dangerous bacteria, posing a threat to all living beings. Microplastics kill living organisms. Plastics have a significant impact on marine ecosystems. Every year, more than 1 million seabirds and 100,000 marine animals die due to plastic pollution. 100% of baby sea turtles have plastic in their stomachs. If a coral comes into contact with plastic, its likelihood of developing a disease increases from 4% to 89%. This is disastrous,
Įsivaizduojat,
as coral
koralai
reefs are home
irgi,
for a quarter of all marine life.
koralams tiksliau kenkia irgi plastikas.
Great extinction that we're undergoing,
Vis tiek,
similar to
tai
the
gyvi
extinction that
organizmai.
wiped out the dinosaurs, will wipe out life again on the planet. And there's some truth to that. Life is being wiped out. I believe it's being wiped out in the ocean by plastic principally right now. It's being wiped out on land by climate change and by plastic.
Microplastics are so tiny that plankton ingest them. Plankton is the foundation of the food chain. Many marine species feed on plankton, and those that don't consume plankton eat creatures that have already consumed it. Thus, microplastics become part of the food chain. The larger the fish, the more microplastics it contains. According to research, the largest animal to ever live on Earth is also